Finding all possible rational zeros using the rational roots theorem, or the rational zeros theorem. Use the rational zeros theorem to list all the possible rational zeros of the following. G of x is equal to 2x raised to the fourth power plus 5x raised to the third power plus 8x minus 7. First thing we want to do is restate the rational roots theorem. If p of x is of the polynomial a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus all the way to what? Let's say a1 of x plus a0. And if p of x has rational zeros, then the rational zeros have the form of plus or minus the factors of a sub 0 over plus or minus the factors of a sub n. Let's apply the rational roots theorem to our g of x function, or our g of x polynomial. So the first thing we're going to do is look at a sub 0. A sub 0 is actually negative 7, and our a sub n here, in this case, is a sub 4, where n equals 4 is actually 2. So our rational zeros would have the form let's see, it's got to be plus or minus the factors of 7 or negative 7. So plus or minus 1 plus or minus 7 over all the factors of a sub n, which is plus or minus 1 and plus or minus 2. Thus, what would our rational zeros really look like? Let's try to put some of these in order. So we could have negative 7 halves. We could also have negative 1 half. I skipped one. Excuse me. I skipped negative 1. So why don't we put negative 1? We could have negative 1 half. What else can we have? We could have positive 1. Oh, actually, we could have positive 1 half. Then positive 1. And then we could have 7 halves. And we could definitely have 7. I forgot another one. The other one would be what? Negative 7. Are possible rational zeros.